we have started recording now, and let me check something real quick. There's a problem. Okay. Oh, you'll get it figured out. Not a big deal. And let's go to the next practice quiz problem. Let me increase the size of the screen. All right. Do parts A and B of number 2. I copied and pasted this, that's why it's a little bit fuzzy. And Landon is setting up our groups a little more optimally, and there might be might need a little bit more time. Unfortunately, I rushed him to do this right before class. Probably would have been better if he'd had more time to set that all up.
That's all right. I'm getting everything sorted up. You can see on the right, and you can see when people are typing in the chat that some people have the rules.
Okay, because they'll be colored. Yeah.
Yep, you can see them, and you can also see on the right everyone's sorted.
Okay. Cool. Okay, let me give 30 seconds more for number 2. Okay, so once again, this is really saying f of anything is that thing plus 2. That's what a function is. It corresponds inputs to outputs. And when we put 7 inside there, we get 7 plus 2 squared of 9, which is 3. Now, this one, when we put a number in here, this was the input to the function. And it went here and here. When we say this is the same as saying find the input when 4 is the output. That's what this is really saying. It's not saying, see, notice how x has been replaced by 7. So clearly the input is 7. The input is x, and f of x is the output. So we replace the f of x with 4. So it becomes 4 equals square root of x plus 2. And then we solve this by squaring both sides. And we get 16 is x plus 2, subtract 2. We get x equals 14. Now, what does this really mean? What did we accomplish? Thus, the input of 14 leads to the output of 4. Function, input, output process. 14 goes in, 4 comes out. Okay. So, give me a brief amount of feedback on number 2. When you're giving the feedback, this is actually an important part of this process. It's this kind of reflection. And like, if you felt that it was valuable, if you can kind of see a little bit of detail about why it was valuable or something like that. Just a reflective process can help clarify things. as you have to write it out. Okay, we'll go over the negative f of a problem. Thanks for asking that, Julie. Okay. Alright, so let me go back. It's kind of neat when that happens. Surprised you did it right. Why did I square the second problem? Alright, let's go with both of those. Alright, so back to the negative f of a. Alright, so let me just clarify something over here. This is negative a is the input. On this one, only a is the input. So you're going to do this one just like we did this one up here. But then you throw an extra negative out in front. So it's the negative of this, but this part gets done first, f of a, and then throw an extra negative just on the outside. And then the other question that was asked for clarifying, which was, why did we square both sides? I need to solve this equation for x. And there's two things I have to do to get x by itself. I have to get rid of this plus 2, and I have to get rid of the square root sign. But I get rid of the square root sign first by doing what's called the inverse. We sometimes think of it as the opposite of square rooting, which is squaring, but we square both sides, and square root and square kill each other off. It's kind of like this. If you had square root of 5 squared, 5 squared makes you up to 25, square root of 25 is back to 5. It's just like these two things killing each other off, getting you back to the original. Alright, let's go to number 3. Consider that relationship. Write the relationship as a function in that notation, and then, once you've done that, evaluate f of negative 3 now, and then solve. So, do number 3. Okay, 15 seconds more. Let me just pop over here. Alright, so you can choose which one, Landon, which group. Alright, so let's go back to this. So, write the relationship as a function r equals f of t is another way of saying solve this equation for r. So I'm going to take 3r plus 2t equals 18. To get the r by itself, I'm going to move the 2t to the right-hand side. And then I'm going to divide by 3. Now I prefer to divide all 3 terms, every single term. Now terms are separated by addition, subtraction, or an equal sign. I'm going to throw that, it's an important definition here. Terms are separated by addition, subtraction, or an equal sign. Okay, then we divide all 3 terms by 3, and then I'm going to get r equals, and my favorite way of doing this is like this, kind of in mx plus b format, so we can see what the slope is. So there's my function. It doesn't have to be written like this. I could have, at this point, another alternative could have been taking 3r, dividing by 3, and just dividing the whole thing by 3. And then you could say that that's your function. That would have been okay too. But my favorite is over here, because I really like mx plus b format. Find out what the slope is and the y-intercept, and very handy and useful. Okay, so that's the answer for A. And then for part B, I now do f of negative 3. So this is implying that this is called f of t. R equals, that's function formation notation. So the r could be, replacing f of t. And then f of negative 3 is negative 2/3 times negative 3 plus 6. And then these negative 3's will cancel each other out. This is just going to be 2 plus 6, which is 8. Okay? So when the input is negative 3, the output is 8 into that function. And then part C says solve f of t is 2. F of t, that's saying the output is 2. So 2 replaces the output side. Negative 2/3 t plus 6 is over here. So let me get a little more space. And to solve this, I subtract 6.
Isn't the 2 negative? Oh no.
Yeah, I think f of t equals positive 2. But thanks for checking for me. Negative 4 is negative 2/3 t. And then I could divide both sides by negative 2/3. But what I prefer to do instead is multiply both sides by the reciprocal. Now, multiply both sides by the reciprocal. And what I wrote down on the right side is correct notation. But what I wrote down on the left side is not correct notation, because that looks like subtract. Negative 3/2 subtract 4. And I need it to be multiplied. To show that it's multiplied, not subtracted, I can put this in parentheses as well. Okay, and then 2 negatives make a positive. The 2 and the 4 reduce to 2, so that's 6. And then everything cancels out. The negative 2's cancel out, the 3's cancel out, and you just get t. Finally, I'll just put it in its forward notation. T is equal to 6. So, part C, solve f of t is equal to 2. The solution of that is t is equal to 6. All right, a little feedback on number 3. Okay, and I can go over B again. Thank you for putting that stuff in. That's really good. Would you do that inverse multiplication to make it easier and faster? Yes. I could divide both sides by negative 2/3, but then I have to do copy dot flip, and it just takes more time. That multiplying by the reciprocal is just a little bit speedier way, and it's a little cleaner. Okay, and all right, so part B, request for me to go over that again. F of negative 3. So there's the function, it's just substituting negative 3 in for the t, and we get this. Now this negative 3 here, anything is itself over 1. Negative times a negative makes positive. And I can just multiply the tops and get 6 divided by 3, which is 2, or I can reduce. As long as everything is multiplied together, no addition or subtractions, I can reduce, and I get this. All right. Let's take a break for a moment here. And at the beginning of class, everybody was supposed to have gone into their group and said hi. If you hadn't done that, do that right away. And group leaders, would you give me the first name of each person that's here in your group? Say group 1 present, group 1 present, and then give me the first names. And if your group leader's not here, then the backup is going to do that for the group. And I'll take roll real quick here. Go over how to get into OneNote. You bet. Okay. Group 3. Amari, Sebastian, Crashy. Okay, and if I could hear from groups 1, 4, 5, and 6. If you could type in who is present, that'd be helpful. And oh, my favorite color might be, let's say blue. And students. Missing students.
You're gonna have to be more specific. Would you like a light or a dark?
Is there another blue already? Give me something different than what's showing up.
Well, yeah. There's group 5 has a dark blue, but if you'd like, I could change them to a light blue. It depends on whichever blue you want.
That'd be fine. And what about the missing students?
Yeah, there are students that just aren't in the server at all. I have no idea where they are. They're just missing.
Are they here today? Like, is Daphne Garcia, are you here today?
Nope, they are not. They aren't in the server at all. They aren't in VC.
Gotcha.
They aren't.
They've never come into Discord. Okay.
Yep, they never. Yeah.
Gotcha.
So that's what I mean by the missing students. And there are 2 students with duplicate accounts. So you might want to get that taken care of.
What should they do?
Well, they must have accidentally created 2 accounts. I can think of a couple ways they might have done this, but they want to delete one of their accounts and only use one of them, or let the other account leave the server.
Okay. All right.
That is if they remember the login. If they don't, then you can kick them manually.
Okay. All right. And we can take care of that at a different time. And all right. So let me see. All right. So we got more information about. Hey, he's great. All right. So let me send you to the next practice quiz problem. Is it a function? For part 1, part 2, part 3. State whether those are functions. Just a simple yes or no as you're writing it down. Okay, 15 seconds more. All right, so on number 1, all I really need to look at is the first letter. And they're all different. It has to have the same first letter and 2 different, so this, yes, is a function. On the second one, I just need to look at the inputs, but holy cow, 2 different inputs, and they have different outputs, so this is no, not a function. And the third one, this is, does it pass the vertical line test? And yes, it does. By the way, this one would not pass the vertical line test, because when the input is 10, there'd be an output of 8 and an output of 14. A vertical line would strike the graph twice. Right there, it fails the vertical line test. Okay, and then, so that's number 4. Is it a function? Let's come on over to here. Type in some feedback on 1 through 3, but don't hit enter quite yet. I need to check off the roll here, so I don't want these sliding past me here. Okay. Okay, go ahead and give me your feedback now. Go ahead and hit enter. All right, and is there anybody who wound up being in a different group now than they were before? I think I had changed 1 or 2 group names, and then I gave Landon the old list of my group names, and I didn't realize that. Anybody feeling like they're in a different group than they were before?
Yeah, make sure you check your roles. You can click your own profile picture, and that'll tell you which role you are, or you can check the color of your name when you send a message in chat. If you're red, you're group 1. If you're orange, you're group 2. If you're yellow, you're group 3. If you're green, you're group 4. If you're blue, you're group 5. And if you're purple, you're group 6.
Okay, and if anybody finds out that they're in a wrong group, just let me know, and I'll have Landon stick you in the right group. Okay. And all right, let's go to number 5. The number of cubic yards of dirt, D, needed to cover a garden with area A, square feet. It's given by D equals G of A. Sounds kind of strange. A garden with area 5,000 square feet requires 50 cubic yards of dirt. Express this information in terms of the function G. Explain the meaning of the statement G of 100 equals 1. All right, I'll give you a minute to work on this. Okay, 30 seconds more. All right, let me have you stop. All right, if you felt lost with this, like, God, I just can't figure out what in the hell they're talking about. What does this mean? All right, let me show you what really helps me on these. I figure out the input variable. Now, what is the input variable? It's the one inside the parentheses. That's A. And I'm going to come up with a little description. And then the output variable is D, the one to the left. And G is the name of the function, but it's not the input variable or the output variable. It's the function that takes you from A's to D's. Okay. Now, it tells you what A and D are, but it's important to list them in order too. A is the thing that gets acted on to produce. The input is what gets acted on by the function to produce an output. Okay. Cubic yards of dirt, D. Well, D has to do with dirt, cubic yards. Oh, but it tells us A, needed to cover a garden with area A square feet. This is the area of the garden. And it's in square feet. And D, number of cubic yards of dirt. Cubic yards of dirt. So that could be written like this, yards cubed. All right. Now, once I write down, this is how I do every problem, math problem that has words, and it's helped me out so many times. I just write out the input variable first, then the output variable, brief description of each, and then that orients me on any question. So, when they said a garden with area 5,000 square feet, I can just look over here. 5,000 is not the D, that would be cubic yards. This is a garden with area 5,000 square feet requires 50 cubic yards of dirt. Okay, express this information in terms of the function G. So, I'm going to do it just like this one right here. D equals G of A, and I'm going to say the input is 5,000. We could put feet squared in here, we can just leave the units off. It's going to give me 50 cubic yards of dirt, like this. That's how it would look in terms of the function G. So this is the answer for A, and then explain the meaning of the term, the meaning of the statement G of 100 equals 1. Well, according to this, the 100 is the A, and this is the D. So 100 square feet of garden requires 1 cubic yard of dirt. If I want to know how much dirt to order and I have 100 square feet, I just need 1 cubic yard. Like this. Alright, give me a little bit of feedback on number 5, please. Alright, looks like getting good on its feedback. Alright. And let's come back. Define, these are two terms that we had last time. Function and relation. Very important. Don't go looking these up. Just in your own words, what do you remember? How would you describe a function and a relation? Super important that you're using your recall here. Seeing what's and the wording of it. It can be worded in so many different ways. That's not so important. It's the idea you're trying to get across here. I'll give you a minute for this. Thirty seconds more. Okay, so let's look at relation first. That's the first thing we looked at. And I had called it an input-output process, or you can put anything with an input and an output. Or two variables. Anything that has two variables, and generally speaking, it's not of interest to us unless they change together. When one changes, the other changes. Okay. And function could be exactly the same thing, or you could put it the way I did it before, an input-output process. But here is the important part, where each input has exactly one output. If it doesn't have this, it's like your cell phone. You hit a 3 on your cell phone, and generally a 3 comes up, but sometimes a 4 comes up. We wouldn't find it very useful. With each input, there's exactly one output. We know what we're going to get. And that's the extra clause that goes on function. Okay. Give me a little feedback on 4 and 5. All right. So let's go. So we are at a break point now. And generally speaking, practice quizzes will take a half an hour, and we'll go till about 1 o'clock with those. We went a little further today. There was a lot to go over. But that might have answered a lot of your questions as well. And what we're going to do now is we're going to take a 15-minute break. When we come back, I'm going to go through domain and range. We're going to, usually at this point, I then answer questions on the homework. But I'm going to flip it around today. I'm going to cover the new material just to make sure that I don't run out of time. Because if you get in this cycle of, like, I have a whole bunch of questions and then I never get to the lecture, then we stay permanently kind of behind, and then it causes more questions next time and so on. So today, I'll go right into the lecture when we come back. We'll cover this material, and what time we have left over, if there is some, I'll answer questions. And then if you had some questions on particular problems that you didn't get answered today, save them for next time. And I'll make sure that I cover questions on Wednesday on both 3.1 and 3.2. All right. We will start again. At 1:32 p.m. Start sharply then. I'll see you in a bit. Anybody need to talk to me at all before I take my break?
Yeah, I was wondering if you can go over how to get into OneNote again. I'm sorry.
Oh yes, I was going to go over that real quick. So there's an announcement. It's the very first announcement. If you go into Canvas, scroll way down to the bottom, and it has a link in that announcement. And so the basic procedure for getting into OneNote is make sure that you have Microsoft Office installed on your computer. If you don't, you can get it free from the community college, and there's links in that in the modules, in Module 0. And then once you have it installed, and then you open up OneNote so that program is active and running, then all you have to do is either click on that link or copy and paste that link into OneNote, and then you'll be able to see everything that's on my screen.
Perfect. I got it. Thank you so much.
Okay, great. Anything else? Anybody else need to talk to me before I take my break? All right. See you in a bit. All right, we're going to start up again. It's looking pretty cool outside now. Snow's starting to come down again. I live out here in El Dorado. All right, we're going to go with 3.2, domain and range. And I have these simple definitions, but it's kind of complex to interpret those and put those into action. The domain is the set of all possible inputs for a function or relation. And the range is the set of all possible outputs for a function or relation. So, state the domain. You put it right, I'll put it right after the D colon in the range for this situation. The input is the miles driven. The output is gallons of gas used. And so what I'm going to ask you to do is in your group chat, type in your answer put D colon and make some kind of wild guess. Look carefully at the definition, and you're going to feel strange about guessing when you don't know what it is, but I'm going to ask you to take that risk and to guess. You'll get way more out of it. And then also put in something for the range, but don't hit enter yet. Type these into your group chat, but I want to give everybody some time to process this first. So let me give you a minute to think about that. Okay, go ahead and hit enter into your group chat, and if you have no idea, you still have to put something. You could say, I have no idea, but you got to put something in to your group chat. And let me give you a little bit of time to process the information you're seeing in the group chat, and you can chat with each other about it. All right, group leaders. One of your tasks today was also to remind the group who is the spokesman for the day. If you haven't already done that, do that right now. And then you're also, the group leader is the backup, and then the backup is the backup for the group leader for if I call on somebody and nobody responds after a little while. All right, group 5, what do you have for the domain?
We said that the domain is miles driven.
Okay, miles driven. Okay, now let's look back at this definition. The domain is the set of all possible inputs. And all the inputs are going to be the number of miles that are driven. Okay, so you're on the right track. But we need to get it even more specific. Now, more specific, I mean like what kind of numbers are allowed. Is like -3 allowed as an input here? Or is 5 allowed? Is 2.3 allowed? So on. And so that gets us going, miles driven, but let me show you a format that I would, there's a couple suggested formats. One is like this. The miles driven has to do with the input, and we're going to call the inputs, in general, we often use X. And in general, for outputs, we don't have to use X and Y, but we often do. X and Y. So the domain is a statement about what kind of numbers X can be. And it turns out, we could say X is greater than 0. because you can't use numbers like -3. You can't drive -3 miles. Now, we also have to ask this question, what about 0 itself? Is 0 a valid input? Well, certainly it is. Some days you're not going to drive your car at all. So then it would be 0, so x is greater than or equal to 0. Now let's go to y. Y, what must be true about y? Gallons of gas used. Well, same kind of restrictions. Can't use negative numbers. So, but you could do 0 gallons of gas because we didn't drive at all. So y is greater than or equal to 0. Okay, we're going to show you another notation. It's called interval notation in a little bit. But for right now, we'll just stick with this. A statement by x and a statement by y, about y. All right, any questions on this? Domain and range. Let's do another one. X, you have a company that just sells lollipops. And they cost $3 each. X is the number of lollipops sold, Y is the revenue. So, same directions. In your group, type domain, D colon, state what it is, R colon, what it is. But don't hit enter quite yet. So thanks group 5 getting us going on that one. And quick reminder, when you're talking, be nice if you just introduce yourself real quick. Just say, you know, I am James and da-da-da. All right, go ahead and hit enter. See what others have. All right, group 3, what do you have for this one?
Sorry.
Oh, you're not coming very good.
Oh, sorry, I didn't have my mic down.
Okay.
D is x is greater than or equal to 0, and R would be 0, 3, 6, 9, 12, etc.
0, 3, 6, 9, 12. And the etc. we'll just put dot, 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 dot. All right. And your name is?
Omari.
Amari. Okay. All right. Amari, I agree with one of these, and I disagree with the other one. And the one that I really like is this. Week 0, 3, 6, 9, 12, etc. This domain is really close because you can't sell negative number lollipops. You want to get rid of those. But this situation is not like the miles driven. Can you drive 2.3 miles? Yes. Can you sell 1.3 lollipops? No. You're going to sell 0, 1, 2, just whole numbers of these. So this situation is fundamentally different than this. Now both of them might have top-end limits, like you only have so many lollipops and you only have so many gallons of gas in your car and so on. But we can just state in general like this. You know. Any questions on these two? All right. Next one. This has no situation involved. Just square root of x. Write the domain and the range. Type in your answers for your group chat. but don't hit enter quite yet. Okay, hit enter. Group 1, what do you have here?
I don't think we have anything entered yet.
Okay, you need more time or are you just stuck on it? You can always say pass.
I personally am a little bit stuck. I'm not sure about the other two ladies.
Okay, all right. Let me call on one more group. Group 4, any ideas here? Group 4,
Hold on a minute. Who's speaking?
who is speaking?
Am I meant to be speaking? Oh, So I I was meant to be talking this entire time. I apologize. Our idea is that D is well. How do I phrase this? For D, X is less than 0, and we didn't really figure out why.
Okay, and who is this I'm speaking to?
Landon.
Landon? Okay, why did you say X is less than 0?
Oh, I messed up. I'm sorry, I read that wrong. I'm out of it today. X is more than 0. Anything more than 0.
Okay, now sometimes we do like to state the opposite. And we like to say X cannot be less than 0. You know, and so I think you might have been on the right track with that. But yeah, let's put it. It must be more than 0. But the thing is you're not allowed to take square roots of negative numbers. Like square root of negative 9, you can't say that that's negative 3 times positive 3. It's got to be a number times itself. When you get negative 3 times negative 3, you get positive 9. All right, but we can also refine this. We have to ask, is 0 itself allowed? Negative numbers are not allowed as inputs to this function. But can you take the square root of 0? Yes, because 0 times 0 is 0. So we'll put x is greater than or equal.
So then X is greater than or equal to.
Greater than or equal to 0. Okay? And then for the range, we would make a statement about y. And y is the same as f of x. And y, well, when you take the square root of any positive number, you also get a positive number. And the square root of 0 is 0, so it would also be y is greater than or equal to 0. So what we're seeing here is when there's a context that makes sense, you have to use reason to figure out what are the allowed inputs, what are the allowed outputs. We have to get very specific. It's a set of all possible inputs. You have to state what are those numbers that can be inputs and outputs for it. And when you don't have a situation, but all you have is an abstract equation, then as long as you don't get illegal values. Now, some values are illegal. You can't have square roots of negative numbers. So you have to disallow those things. Other than that, we don't know anything about the context, so we say everything else is allowed. Okay. So we always take the biggest possible set that we can think of, as long as it doesn't give us illegal values. All right, so let's go to this next one. Let me give you a minute. Type in your answers in your group chat, but don't hit enter quite yet. Okay, go ahead and hit enter. And again, if you can't figure out anything, you still got to be typing something in. Like, you can just say, I'm stuck, but you got to give your group some feedback. Something that they can say, they can report. When I call on a group, they say, you know, 2 out of our 4 people are stuck, you know, or 3 out of our 4 are stuck, whatever. That's all good information for me. All right, so on this one, I'm going to do this one. For the domain, I'm just going to start plugging in some random numbers. And like if I was to make a table of values here, and I was to put in like 0, can I do that? Well, I'd wind up getting square root of -10. So 0 is not allowed because it gives me negative inside a radical. So, you know, when I get up to 5, that's still going to give me a negative number inside there. If I get up to 9.9, that's still going to give me a negative number inside the square root sign. But as soon as I get to 10, I'm okay. 10, I get square root of 0, which is 0. And then 11, I'd get square root of 1, which is 1. All of these are fine. So I am seeing x greater than, at first I might be tempted to say greater than 9. But look at 9.9 was not allowed. Where was the first one that was allowed? It was 10. 9.999 is not allowed, but 10 itself is allowed, greater than or equal to 10. And the range, now when I put 10 in, what am I going to get as an output? 0. And then I'm going to get bigger and bigger numbers as x is bigger than 10. So the y will be greater than or equal to 0. I'm going to get that 0 when x is 10, and then but I'll never get negative numbers. When you take the square root of a number, you're going to get a positive result each time. Any questions? All right, let's go to G. G of P is square root of 5 minus P. State the domain, state the range. Okay, I'm going to do this one as well because these get kind of tricky. All right, and what I'm going to show you is before I do this one, I'm going to show you an alternate way I could have done the previous one. I could have circled what's inside of here, and I could have stated the part that's circled, once it's resolved, like if x is 11, you do 11 minus 10 and you get to 1. So the result after you subtract 10 from it. What must be true about this is that it must be greater than or equal to 0. So that when x is 11, you're going to get something that's okay. When x is 9, 9 minus 10 is not greater than or equal to 0. Okay. Once you have this, then you can solve this inequality. And that is the same as the domain. So let's go down to this next one and create a little space. All right. One way to do this is start picking some values. No, it's not x. It's p and g of p. Okay. If I plug in, like, let's say big negative numbers, like negative 10, is that okay? I'm going to get square root of 5 minus negative 10, which is actually the square root of 15, which is fine because it's the square root of a positive number. When I do other negatives, like negative 2, that's okay. When I get to 0, that's fine. When I get to 4, that's fine. Square root of 5, I'll leave it like that. Square root of 1 is 1. When I am at 4.9, it's square root of 0.1, and that's fine. As long as it's not a negative number inside the radical. When I get to 5, I'm okay. But as soon as I get bigger than 5, this is not allowed. 10 would be square root of negative 5. It's not allowed. Any of the numbers bigger than 5 is not allowed. It looks like from my table that I'm drawing, x is less than or equal to 5. And if x is negative, that's okay, because then this will be a double negative. But if x is too big, we have problems. Okay. Now this was kind of time consuming. There's an alternate way, faster way to do this. Either way is fine, whichever way you like. Or you can do them both ways. I often do things more than one way. After we substitute a number for p and figure out what 5 minus p is, the final result of 5 minus p had better be greater than or equal to 0, because it's inside a radical. So I have to solve this. Negative p is greater than or equal to negative 5. Now I'm going to divide both sides by a negative number. And from a previous course you might remember that when you multiply or divide both sides of an inequality by a negative number, you have to switch the sign of the inequality. P is now less than or equal to 5. And that's the same as the answer I got before. I should never have called it x. That's p. And the range is a statement about the output. And we could call it y, or we could call it g of p. G of p. When you take the square root of something, you always get positive, you never get negative. So g of p would just be greater than or equal to 0. Any questions on this? Alright, again, two ways to go about it. It gets even harder now with this one. So the harder they get, the more the second way is helpful. So I'm going to give you a minute on this. I'll kind of back up a little bit so you can see a little bit of the other technique that we used in the previous problem. I'll give you a minute. Okay, go ahead and type in your, hit enter in your answer in your group. Check out what others in your group have done. And group 2, what do you have for this? Group 2, are you with us? Let me check. Jasmine, are you here?
Yeah, I am. We were kind of confused on the speaker.
Oh,
Trying to figure.
okay. All right. And what do you got? If you could just fill in, Jasmine.
It was a little bit of a mixed bag. X is greater or less than 4, and then for Y it's greater or equal to 0. Yeah.
Okay. That is a very good start. Let's look at that. Okay. And instead of X, we'll go ahead and use W. W, you're saying greater than or equal to 4. That'll get us rolling here. All right.
It was less than.
Less than, okay. And let me get to my eraser. All right. Less than or equal to 4. All right. Now, it's part of this that really makes sense. If I use any number smaller than 4, like even a negative number, like negative 10, I'm going to get 9 minus 2 times negative 10 all under a square root. Well, that's 29, positive 29. So that's fine. Negative numbers are fine. And when you get all the way up to 4, you're still fine. Because you get 9 minus 8, which is square root of 1, which is 1. But we can change our magnifying glass to now look really closely around 4. Could I use 4.5? Well, let's look. Double 4.5 and you get 9. Square root of 0 is 0. So, we could use 4.5. But could I use 4.6? 4.6. All of a sudden, the 2w is going to be bigger than 9. This is going to be square root of 9 minus 9.2. And it's negative 0.2. So this one doesn't exist. So, really good start. 4, but let's just modify it. We can go all the way up to 4.5. Now, we could have also gotten that by saying, let's look at all of this. What must be true about all of that? It must be greater than or equal to 0. It must be resolved to be positive. Now let's solve. We will divide. When you divide both sides of an inequality by a number, we reverse the inequality. And we get W is less than or equal to 4.5, which is exactly what we were coming up with. And you all had stated the range. The range is greater than or equal to 0. That's right. When you take the square root of something, you're going to get 0 or larger. You're not going to get negative numbers. So, thanks for pushing us in the right direction there. And, all right, the next three problems are going to set us up.
I do have a question.
Yes.
So for the previous problems, we put, so for the domain, does it matter if we put W is greater than or less than, or do we have to put X and Y?
I wouldn't mark it wrong if you put X, but generally speaking, you can see this is the input letter, W. So
So it's better to
it's better to put W when you're going to put
Wait, thank you.
for the domain. Yep. Okay. And was that it for your question? Everything else okay on that?
Yes, sir.
Okay, good. Thanks for popping in and asking. That's what I'd like you all to do. All right. Let's go to these next ones. Find your result and check your work. There's a quick way to check your work in division. So let me give you a quick minute on these. All right, let me have you stop. This is equal to 4, and I can check my work by taking 4 times 2 equals 8. That times that's going to give you that. So, if we do this again, 0 divided by 3, I'm going to guess 0. And then I'm going to check my work. 0 times 3 is equal to 0. That checks. I'm going to guess 0 on this last one. But then when I do 0 times 0, ooh, I don't get 5. Alright, this one is a problem. And you can see that it won't check. That's the first indicator of a problem. Okay. The other thing that we really need to become aware of with these divisions is the essence of what division really means. When you're in elementary school, it's commonly taught that here's 8 cookies divided equally among 2 kids. Each kid gets 4 cookies. All right. Now, that model struggles to explain over here. 5 cookies, when there's 0 kids, how much does each cookie kid get? It doesn't answer the question. We need to generalize this a little bit more to the real idea behind division. The real idea behind division is this. How many times bigger is 8 than 2? Or, how many 2's do you have to add to itself to get 8? So we'd say we add 2 to itself. Four times. Or in other words, this is 4 times bigger. Thus 8 is 4 times bigger, times larger than 2. Alright. Now, if we use this idea, this bottom one becomes clear. How many times bigger is 5 than 0? Or how many times do you have to add 0 to itself before you get to 5? Well, if I add an infinite number of zeros together, I'm still stuck at 0. This fraction is even bigger than infinity. That's why we say this one does not exist. You cannot put 0 in the bottom of a fraction. 0 in the top of a fraction is fine. How many times bigger is 0 than 3? Well, it's 0 times bigger. And it checks. These times this is this. But this doesn't make sense. And how many 3's do you have to add to itself to get to 0? You add 3 to yourself 0 times, and you get to 0. But this, there's no way we can make sense of that. Even if we tried to use an infinite number of zeros, it's not big enough. A zero added to itself an infinite number of times still stays at 0. All right, so it's bigger than infinity, this ratio. All right. When do we call a fraction undefined? Meaning that it's an illegal fraction. The answer is when 0 is in the bottom, or the denominator. Can't have 0 in the bottom of a fraction. All right. So, with that in mind, look at this one and state the domain and the range. Type in your answer to your group chat. And go ahead and hit enter. And let me go to group 1. What is the domain on this one? Group 1. So Valerie, group leader, are you there?
Yeah, I'm here.
Okay. What do you guys have?
Natalie put the domain. I'm sorry. The domain is like 1, 2, 3, 4, 5, 6,
Okay.
7. Anything higher?
Okay, so you got a possible result. So that's a good way to look at it at first. Is we could just say, what are possible inputs to this? So on. Now, is there anything in here that prevents us from putting in fractions? Could I put 1.5? It's not like the lollipop situation where you can't break lollipops into pieces and sell the pieces. So we might put all the numbers in between here as well for the domain on this. And then let me go to one more number before I go to the dot, dot, dot. What about 7? Is 7 okay as an input? Well, if 7 is an input, I'm going to get 0 in the top. Is that okay? The answer, yes. It's only when it's in the bottom that it's a problem. Now, if we just look at the positive numbers, though, we won't see the difficulty. What would make this one 0? Because that's what we have to avoid when 0 is in the bottom of the fraction. That one is going to be, let me, oops, get my eraser. -4. And the shortcut way to write this is this. X cannot equal -4 because it makes the denominator of the fraction 0. X can be any other number. It could be 7. If you're making the numerator 0, that's fine. You just can't make the denominator of a fraction 0. And the range is going to be all real numbers. You can get any number you want out of this. And we have a shortcut notation for that. Instead of writing all real numbers, we just put a double bar and a capital R. That means all the real numbers. All right. We are running out of time, so let me quickly run through these last ones. I'm going to tell you the domain here is X cannot equal 2, because that would cause 0. 3 times 0 times 3. Well, as long as there's any zeros in this multiplication, the whole result's going to be 0. And another one, x cannot equal -1, because that would cause this part to be 0. Some people write it out. X minus 2 cannot equal 0. So x cannot equal 2. You could do that on both of these cases. Or you could just look at it and say, these are the two numbers you can't have. And then the range is going to be all real numbers. You can get anything you want out of this, but you can't allow these two as inputs. All right, now the assignment, the homework, is this section 3.2 on domain and range. And the groups, I want you to get together outside of class, and in the 3.2 I want you to check number 40. Let me see what we did on here. Groups, check 3.2 number, and I have a number written down that didn't make sense. So let me quickly look in my book. Number 60. So, when your group gets together in some remote fashion, outside of class, go over number 60 together. Make sure everybody understands it, make sure everybody agrees on a common answer. Make sure you do that problem individually first before you get together as a group.
I have a question.
Yes.
So you told us not to take pictures of our homework. What is the app called where we...
The app for taking pictures of your homework?
Yeah, because you said you didn't want pictures, you want us to scan it.
Yes. There's a lot of different scanning apps for your phone. I use the one called Fast Scanner. And I've been, it's free and I've been happy with it. And it has a batch mode. So I use that to, put lots of pictures into one document. All right? Any other questions? All right, I will see you all on Wednesday. And let me stop the recording.